Hi everyone, in this video we are going to discuss the difference between a nuclear explosion and a chemical meltdown. And so a nuclear explosion is usually something that happens where you have uncontrolled chain reactions that occur inside of a nuclear power plant and you have this horrible, awful explosion. Sometimes you could also refer to a nuclear explosion as an atomic bomb, okay? A chemical meltdown is usually some kind of fire or a very, very large exothermic chemical reaction that occurs inside of a nuclear power plant. And so what we're going to do in this video is talk about the explosion that occurred at Chernobyl and try to classify it as either nuclear or chemical. So let's start off with a little bit of background information. So we had this nuclear power plant. It was located in Ukraine, and unfortunately in April of 1986, something horribly, horribly awful went wrong. And usually this is considered an operator error. And so what happened is they were using some kind of training exercise and they were trying to train, or maybe they were trying to check how things went for their safety procedure, and something went wrong. And so let me try to use an actual schematic of a power plant here to illustrate what happened, try to give you a visual. So remember, in the nuclear power plant, what is super important is we have this thing called a primary coolant. And so the primary coolant is a liquid. Usually it's some kind of boric acid that has a boron in there because it readily absorbs neutrons, which is good. It's another safety protocol or safety measure. But basically what they did at Chernobyl in April of '86 is they basically stopped the flow of the primary coolant. And so they made it, so they just kind of turned it off while they were checking some safety stuff. And unfortunately, their control rods were not fully inserted. They were kind of half out. It's not very clear exactly how far in or out they were, but it's very evident that they were not all the way in. So they turn off the flow of the coolant, the control rods are not inserted, and so what we would all assume to be happening is the fuel rods are continuing to go through the procedure and they're continuing to release an insane amount of energy. So very, very rapidly the temperature increased, okay, of the primary coolant. So the temperature just whoosh, shot through the roof. Now, what we recall is we have this steam generator right next to the control rods and the fuel rods, and that is just full of liquid water. And as soon as the primary coolant comes through, when it's usually warm, not really, really hot, what happens is that liquid water is able to turn into steam, and that steam is what goes through and powers our turbine generator, so on and so forth. So now, what happened then is because the primary coolant was so freaking hot, the liquid water in the steam generator instantly turned into steam. And so all of a sudden, something with medium kinetic energy all of a sudden has a lot of kinetic energy, and there was this huge explosion, okay? Just because of the transformation of liquid water to gaseous water. That is what happened, okay? It is not a nuclear reaction, it's the conversion of liquid to gas of water. And that has such a high amount of pressure that it burst all the pipes, everything there, and there was this huge explosion. So then the big problem is that it shot graphite into the air. So graphite went into the air, it came back down, and then what people said, oh my gosh, we need to put this fire out, because now it's fire, right? They tried to spray the graphite with water. Biggest mistake they did, because the graphite is so incredibly hot that as soon as the liquid water hit the graphite, it split the water, creating hydrogen gas. As soon as the hydrogen gas interacted with oxygen gas, which is 21% of our atmosphere, there was a massive explosion. So there was one explosion followed by so many more explosions, and that had fires that lasted for 10 days. Over 31 firefighters and plant operators died because of this, and not to mention over 250 million people, so just people, citizens that are around the area, just happen to live there or be visiting there, were exposed to horrible, horrible radioactive illnesses. It was really, really bad, and this was all operator error. It was a human that made a mistake. Like, this was 100% preventable. This should not have happened. It would really, in my opinion, the person was not trained enough. Here's an example. This is a picture of Reactor 4. There were 4 reactors there. This is Reactor 4, slightly after the fires were put out, so this was very soon after. And then I also have an aerial view here. This is also of Reactor 4, so you can kind of see it right here, down, kind of a top-down view of it, and you can see how it just basically had this huge explosion because of the water converting to steam, and then we released the hydrogen gas when we sprayed the graphite with the water. It was a huge, 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 huge problem. So now, remember, the point of the video, was this a nuclear explosion or was it a chemical meltdown? Very, very important. Which one was it? Go. All right, did you get an answer? Hopefully you did, because I said it like 45 times, but just in case you didn't, it was definitely a chemical meltdown, okay? It was not anything to do with the nuclear rods, the fuel rods. Nothing went wrong with the nuclear reactor. What went wrong is somebody turned the cooling system down that's necessary in order for a nuclear power plant to function properly. It was 100% operator error, and it was 100% a chemical meltdown. It was not a nuclear explosion. Okay, that needs to be very clear. All right, so now the second thing I want to point out specifically with Chernobyl is what they had is they shot a lot of iodine-131, which with an atomic number of 53, into the air. And this was a huge, huge problem because the iodine then went into everybody's system. But let me give you the reaction here. And so it created xenon-131, and it emitted both a beta particle and a gamma particle. Okay? The big problem, and we found out much, much later, is that iodine-131 causes thyroid cancer, which is no joke. You definitely want to avoid that if you possibly can. It's not good. I have a friend going through some of that, and it's really sad, actually. I don't like dealing with that. But basically what happened is, since this explosion, greater than 5,000 children were diagnosed with thyroid cancer. And so not only were 250 million people exposed to these radioactive materials, but over 5,000 children, like little children, innocent children, were diagnosed with thyroid cancer simply because of this chemical meltdown that happened due to operator error. And so let me show you kind of a map of what are considered hotspots now. And so if you do travel, I would highly consider, or kind of maybe demand, to make sure that you look and know exactly where you're going. Make sure you're going to a safe place. So if you're looking at going to currently what we call Belarus or Ukraine or even certain parts of Russia, make sure you're aware of what could be out there still as a result of this Chernobyl explosion. And so if you look at this graph, the deep, deep red color is what's considered confiscated or closed. So they don't even let people go around there. The more purpley color is a permanent controlled zone, and then the pinkish ones are an unnamed zone. Still, personally, I will not go anywhere near these specific areas. I will go to the beautiful Russia, visit Russia, but you want to make sure you're not in these areas that have any exposure, because you want to protect your health, okay? You don't want thyroid cancer or any other number of things that could possibly happen. All right, that's it for this video. I'll see you out there. Bye.